All right, 3.3, the factor theorem. Okay, when we think of factors, we want to think of numbers that actually divide into a value evenly, that where you do not have a remainder. So if we consider the factors of 24, right? 1, 2, 3, 4, 6, 8, 12, and 24 would all be considered factors of 24. These are all factors because when divided, the remainder is 0. Okay, so why is 5 not a factor? Because when you divide it, it doesn't divide it in evenly. You're going to end up with a remainder value, or if you were to divide it, a decimal value. So when we talk about an x squared plus 5x plus 6, we've learned in the past to factor this. And so when you're factoring it, right, we know the factors of this are going to be x plus 2 and an x plus 3. So why are these factors? Because if I take substitute in a negative 2 into this polynomial, I get a remainder of 0. And when I substitute a negative 3 into this polynomial, I will also get a remainder of 0. So why is something a factor of when something is a factor of a polynomial, it will give a remainder of 0. X minus 2 is not a factor because if I were to substitute a positive 2 into this polynomial, I get a remainder of 20. So because this remainder is not 0, x minus 2 cannot be a factor. Okay, so this brings us into what we call the factor theorem. States that if x minus a is a factor of a polynomial, p of x, if and only if p at a is equal to 0. So this can only be a factor of the polynomial if the remainder at a is going to equal 0. So determine whether x plus 2 is a factor of x cubed plus 5x squared plus 2x minus 8. Well, rather than trying to factor this, we can just figure out the remainder by substituting in a negative 2 into my polynomial. And evaluating all this on my calculator, I get a value of 0. Therefore, x plus 2 is a factor of p of x, the polynomial, since the remainder is 0. Okay, so as a quick investigation, which of the following binomials are factors of x cubed minus 7x plus 6? So we'd literally want to try each of these. So A, you'd want to find p at negative 1, and that should equate to 5. B, p at positive 1 is equal to 0. C, p at negative 2 equates to 12. D, p at positive 2 equates to 0. E, p at negative 3 is equal to 0. F, p at positive 3 is equal to 12. And G, p at negative 6 is equal to negative 168. And H, p at a positive 6 is equal to 180. So when by kind of guess and testing, looking at all of this, my factors for this polynomial end up to be a x minus 1, an x minus 2, and an x plus 3. All right, so the goal today is to we have learned how to factor a quadratic, no problem, using Lucky method or decomposition. Today our focus is going to be a little bit on factoring a polynomial that is a higher degree than a quadratic. So we're going to learn how to factor an x cubed, or even an x fourth, or even an x fifth. Or you could really like go on forever, but the highest we go is basically x to the fifth. Okay, so why do you think I chose all of these factors to try? Well, when you look at all of these values, 1, 2, 3, and 6, these all are factors of the plus 6. So this is a key starting point. What I want to do is I want to try and find at least one factor that relates to this 6 that will give me a remainder of 0. So you might end up having to try 2 or 3 before you actually get to a start point, but unfortunately that's where you start. Okay, so we call this the integral zero theorem. The relationship between the factors of a polynomial and the constant term of a polynomial is stated in the integral zero theorem. Integral zero theorem states that if x minus 0 is a factor of a polynomial p of x with integral coefficients, then a is a factor of the constant term p of x. The integral zero theorem will help to simply factor a polynomial expression that has a degree larger than 2. Alright, so when it asks you to list all the possible integral zeros, so integral zeros relates to just the factors of that constant value. So all the possible integrals would be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So technically there are 8 possibilities that could work here. So what we want to do, in order for something to be a factor of a polynomial, it has to give us a remainder of 0. So this is a really important thing to remember. Anytime something is a factor of a polynomial, its 0 value will give us a remainder of 0. Okay? So basically what we got to do is we got to figure out the first factor. So in order to figure out the first factor, you literally have to try all of these values until you get to a point where you get a remainder of 0.